So the front suspension is going to be a little bit different in making it up, and that is because I'm going to be using the standard geometry that comes off the Mark 1 Golf. I'm not going to be changing too many things, just little minor details. At a later date, I might mess around and change a few things, but for now, I just want to get the car on the road. So yeah, most of the stuff is just going to stay exactly the same. So in proceeding with this, I don't need to scan in any of this bodywork. All that I'm going to do is I'm going to use the lower control arm and keep that geometry exactly as it is. So it's still going to mount at this point. It's going to have a ball joint at this point. The only difference is I'm going to make it so that I can adjust the lower control arm to move the wheel forwards and backwards in the weld. I'm still going to use the McPherson strut, and here are the two spindles showing the difference between the Audi TTs and the Mark 1 Golfs. So I still want to use this spindle here. I want to use this connection, and the reason for that is because you can adjust the camber at the lower point as well as at the top. I'm going to be putting in camber plates, whereas on the TT it's a fixed connection. You cannot change that angle of the strut coming out of the spindle. So that was the one reason. The reason why I'm not using the TT's spindle is, for one, because of that reason, and another one is because of the distance from this CV joint axis to this lower ball joint here. It's quite a big distance if you compare it to the Mark 1. So it might have worked, but it's a lot of work to see might. So I've decided rather to stick with the geometry from the Mark 1s. The reason why I'm not sticking with this hub is because of the size of the CV joint that's used. This uses a 22 spline, I think it's 20 or 22 spline, whereas the Audi uses a much bigger 36 spline, I think. The bearing itself on the TTs is much bigger. So I didn't want to use small little CV joints with, 250 horsepower, maybe a bit more at a later date. So the first thing I'm going to do is scan in this hub, and then again we're going to pick up on these 2 points, this point, and where the lower ball joint is. I'm not going to use the Mark 1's lower ball joint, just purely because this geometry here is a bit funny to make up. So all I'm going to do is I'm going to use the Audi TT's ball joint and then transfer that onto my new lower control arm. So onto the drawing board, and let's get drawing.
So if I just turn off visible edges, shaded view, there we go. So the scan came out pretty good. I didn't try and make it perfect to fill in all these little voids. It just wastes time. I've got what's important, which are the locations of these holes here, the axis of this ball joint and the face of this spindle. So I'd previously drawn in this hub from the rear suspension. So all that I had to do was place it on here and align the axis in the correct orientation and the face of this hub. Then I could start drawing out all the parts. So that's pretty much what I came up with. This plate here, I went a little bit thicker than the standard. The standard is 20 millimeters, and I went to 25, and that's just purely because of the coilover system that I'm using, mates up to 25 mils. So the only difference with this hub is, if I just hide this, is I'm not using the Mark 1 ball joint here, and that's just purely because of the way the bolt and the way the whole thing bolts together. I'm going to use the Audi TT's ball joint, and I'm going to machine up a bush which has the taper lock, and then just push the bush in and then weld it in place. The reason for this is if I make a mistake on this part, then I have to scrap this whole piece of metal and then order it again. I just waste so much time. Whereas if I mess up a bush, I just have to remachine the bush. Yeah, that's it. So from here, I can carry on with the scanning and scan in the rest of the components. So I didn't bother to scan in the Audi TT's ball joint here. Just quicker just to take some dimensions and draw it in by hand. It's just a flat plate, extruded, a few circles, and then the only thing that was important was getting this axis here at the right angle. And that's it. Okay, next component to scan in was the control arm. It came out pretty good. Again, the important parts to pick up was this hole here, this location here, the distance, even though I will be making my control arm adjustable, and this needs to be a little bit shorter because I'm pulling the wheel in just a little bit. So from there, I started laying it out. If I just turn the graphic off. So that is pretty much what I've come up with. And then over here, I've got another arm that's going to be coming in. You'll see in the next drawing. It's all 32mm tubing, a few laser cut parts, the RDTT lower ball joint, and then an M14 hind joint in the back there. Oh, sorry, this is an M16 hind joint. The one that fits in here is an M14. Okay, here is a drawing showing the assembly. Even though it's just a part drawing, it just gives a good idea of how everything's starting to lay out. The lower control arm, that is the adjustable connecting rod, which will allow me to change the camber and the caster on the front wheel. The coilover, I haven't drawn in this piece here yet, which connects up, but that gives you an idea of what I'm going for on this version. So the last thing to do is to export the drawings ready to send to the laser cutter. So all that you got to do is open up the drawing, click File, Save As, select DXF from the drop down, click which face you wish to export. So for this drawing I'm going to do this face, say OK, and there it gives us the 2D drawing ready for laser cutting. So now I save the drawing, and in the description I put the thickness and the quantity of the amount of parts that I want. It just makes it a little bit easier for the laser cutter guys. So if I have to do, for example, this face, say OK, and there it is. Easy as. Talking about laser cutting, let's have a look at how the parts came out.
Next I've got a chamfer this edge, just for a nice weld when I weld these two together. So the next thing to do is to machine up some bushes like this, and these are simply going to slot into this hole and then going to be welded in. So it's important to get that angle of that taper correct, because the bottom ball joint locks on that taper. So when these two fit together, you can see they lock together. So that's the next mission, is to make another one of these for that arm there. And then I need to do the same thing for the steering arms. I need to make two bushes that are fit in here and in here. Both spindles, or knuckles, whatever you want to call them, are pretty much done. The next move is the lower control arm. But I think what I'm going to do is I'm going to stop the video here, because it's already getting a bit long. What do you guys think? If a video is about 10 minutes long, is that good? Or would you prefer something longer, like 15, 20 minutes, half an hour? I know so many guys have got short concentration spans, and do you want to see more how-to content, or just general videoing as I have been doing, or do you want to see the intricacies of actual designing? Let me know in the comments if there's something specific. If you haven't liked and subscribed yet, please do. It certainly gives me the motivation to make these videos. Yeah, see you in the next one.